Today, we will have a continuation on the lesson for inverse functions. We have introduced what an inverse function is on the previous lesson, and today we're just going to be seeing more challenging questions, but the main idea remains the same. The inverse function is a function that reverses what the original function did. Basically, we're just going backwards. So here's the main idea. We introduced the concept on the previous video. Now let's do some more challenging questions. Now, let's look for example, number one. Again, they're asking us to find the inverse for the following functions. Now, again, we have series of steps where the first step is if your function is not in terms of y, write it in terms of y. So let's do that first. So now we have y, because remember f of x, you can write it as y. So if we're going to change your original equation, we're going to have y equals x cubed, or to the third, plus 2. So that's always the first step. Just write in terms of y. The second step is the most important. You're going to flip the x's with the y's. So if I see a y, it becomes an x. And if there's an x, it becomes a y. So notice that it is the same equation. We just flip the x and the y's. And lastly, our last step is to solve for a new y. So we want to solve for this y. So what we should do first is we're going to subtract 2. So now this becomes x minus 2 equals y to the third. So we're almost done. We want to solve for this y. Every time you want to get rid of an exponent, you got to do the opposite. And the opposite of an exponent is the root. So we got to take the root to both sides. Now, what's the exponent that you want to get rid of? You want to get rid of the exponent of 3. So you got to take the third root to both sides. Because this root, you're going to cancel out with the exponent. And now you just solve for your new y. So now this becomes y equals the cube root of x minus 2. So it is true that this is our final answer. This is the inverse function where we got to use the correct notation. And remember that when we're using inverses, the notation that we're going to be using is f negative 1. So our final answer is f negative 1 equals the cube root of x minus 2. Well, let's do our final answer in red. So here's our final answer. This is the inverse function of the original. And we're done. Now, let's look at example 2. Here, again, the first step, it's always the same. If it's not written in terms of y, you write it in terms of y. So we're going to change that f of x with the y. So now we have y equals 2x minus 2. Excellent. Second step, we're going to switch those x's and y's. So now, after the inverse, our new equation is going to look something like this. All we did, we changed the x with a y. There was a y, now I put an x. There's an x, now I put a y. And now lastly, our last step is to just solve for y. So let's see, we have y to the second here. I need to get rid of this negative 2. I apply the inverse, which is addition. And now we have x plus 2 equals 2 to the y. Okay, so now you have many tools here. You want to solve for y, which is an exponent. The only method that we know so far is when you want to solve for a variable that is on your exponent. So we got to take the log to both sides. Every time, if you want to solve for a variable that is on your exponent, take the log to both sides. So now we have log of x plus 2 is equal to the log of y to 2 to the y. Now, what was the whole purpose of taking the log? Because when you take the log, if you remember your properties, the exponent can be brought down as a coefficient. So let's continue our problem here. So now this really just becomes log x plus 2 equals y times log of 2. Now it's Pretty straightforward what we should do next in order to solve for y, because remember, if you find the inverse, we're solving for the new y, which is right here. So you want to leave that y alone. You got to get rid of that log of 2. That log of 2 is multiplying, so that means that we need to divide by log of 2 on both sides. So they cancel out. So now we know that y holds a value of log x plus 2 divided by log of 2. This is our final answer. We got to use the correct notation, which is f negative 1 equals log of x plus 2 over log of 2. Notice that the steps are always the same. The only thing that is going to change from problem to problem is where is the y located at. If it's on your exponent, you take the log. That's what we saw in this example. Now, let's look at the third example now. Third example here. Don't look at 4 yet. Let's see. What do we know about 3? Again, first step, it's always the same. When we're finding the inverse, if you write in terms of f of x, we'll write in terms of y. So now we have y equals ex plus 3. Good. Now that you write in terms of y, we got to switch those variables. Every time you see a y, you write an x. And every time you see an x, you write a y. So this is what we have so far. Now notice here that we have the Euler number, e. It is true that you want to solve for the variable, which is on your exponent. But every time you have an e, we don't multiply by the log, but we multiply by the natural log. And the natural log can be written as ln. So instead of taking the log to both sides, we take the natural log to both sides. So now what we have here is ln x equals ln e y plus 3. Now the reason that we take the ln and not the log, it's because we know that for ln, the base is e. And when the base is equal to the number that we have inside the log, they will cancel out. So now what we have here is ln equals just y plus 3. And now it's pretty straightforward as to how we need to solve for y. Well, let's subtract 3. Let's finish the problem here. So now we're going to know that y is equal to ln of x minus 3. This is our final answer, where we got to use the correct notation. F minus 1 is equal to ln of x minus 3. Again, if there's a rule of thumb, if you see an e and you want to solve for the variable that is on the exponent, just take the ln, because ln, it's always going to have a base of e. And when the base is equal to the number that it's inside ln, they will cancel out, and that's why we just bring down the exponent. So that's a rule of thumb. If you have an e, you take the ln, don't take the log. Makes things a little bit easier. So now, finally, let's look at example 4. Okay, so this is what we have so far. Again, the first step, it's always the same. If it's not written in terms of y, you write it in terms of y. So let's do that first. So now we know that y equals log of 2 x plus y. Second step, it's always going to be the same. You switch the x's and the y's. So now we know that x is equal to, oops, we're not taking the natural log, taking the regular log. So log 2 of y plus 5. So this is what we have so far. Now we got to think, okay, so how do we solve for y? If you have a y, or whatever variable you want to solve for, inside the log, we got to apply the definition of the log. And the definition of the log says the base, which in this case is 2, is going to have an exponent. And the exponent is the other side of the equal sign, which in this case is x. So now we're going to have 2 raised to the x equals the expression that we have inside the log, which in this case is y plus 5. Again, all we did here to come up with this is just the definition of the logarithm. If you're still unsure about this, go back and find the video that talks about the definition of the logarithm, and you will understand why we're able to do this. So now that we have this, all we gotta do is just solve for a new y, which is pretty straightforward. Let's subtract the 5. So now we know that y is equal to 2x, 2 to the x, minus 5. This is our final answer, but we gotta use the correct notation, which becomes 2x minus 5. This is the inverse of the original function here. Now, here's your entrance ticket. Find the inverse for the following function.